2.1 Functions, Part 2. Now earlier we talked about something called a domain. A domain is the set of all your x's. It tells you what you can plug into your equation and what you cannot. So let's take this equation. F of x equals x squared plus 5x. In this case, the domain would be all real numbers, since the function tells us to square something and then add 5 times that same thing. Since you can do that with any number and you wouldn't get something that's impossible, the domain is all real numbers, and that's the symbol for that. Now let's say you had something like f of x equals 3x over x squared minus 4. Now, the one place where it might be impossible for a function, for an x to exist in this function is right here. Something would be undefined if this denominator equaled 0, since you cannot divide something over 0. So to figure out the domain, we figure out when this denominator could equal 0, and that happens at plus or minus 2. Since either 1 squared would equal 4, 4 subtracted by itself would be 0, and we want to avoid that. Therefore, the domain of that would have been x, such that x does not equal plus or minus 2. This implies that it is all reals with the exception of plus and minus 2. The third example of something to look out for is if, say, f of x equaled the square root of 4 minus 3x. In this case, it would be impossible to have a square root of something that's negative. So in order to figure out what the domain is, we take the thing from underneath the square root and we set it in an inequality. 4 minus 3x must be greater than or equal to 0. And when does that happen? Negative 3x must be greater than or equal to negative 4 divided by negative 3. X must be less than or equal to 4/3. Therefore, the domain for that would be x, such that x must be less than or equal to 4/3. Again, this implies that it is all reals, except it has to be less than or equal to 4/3. So the two things to look out for really are when a function has something over something that could equal 0, or when a function has a square root. These two instances are when it is possible for a domain to not be all real numbers. Now let's think about this in a more real-world situation. Say you have a circle, and you have the radius r. We've replaced a with, replaced f of x with a. This is the equation to find the area of a circle. Now, what would be the domain of this? If you think about it realistically, the domain would be radius such that r is greater than 0. Do you see why that is? Because technically the radius of a circle cannot be negative, nor can it be 0, because then it would no longer be a circle. Functions can be added, subtracted, multiplied, or divided, like anything else. Let's say that f of x and g of x are your two functions. This is how it would look like if you added, subtracted, multiplied, and divided these two functions. This, on the left-hand side, is called the sum function, the product function, the quotient function, and so on. Whenever you see something like this, all it means is for you to add those two together, or to subtract, or multiply, or divide. Now, an important fact to keep in mind is that the denominator, the function can never equal 0. Now let's try it out. Say you had a function f of x equals 2x minus 3, and a function g of x equals 1 over x squared. And you were told to f minus g of x. So what do? This equals f of x minus g of x, as we learned just now, which means if we just plug it in, 2x minus 3 minus, now the parentheses are important now, 1 over x squared. So that was 2x minus 3 minus 1 over x squared in parentheses, and very easily simplified, 2x minus 3 minus 1 over x squared, and that's it. Of course, you can always try this with more difficult ones, but it all works the same way.